Hello, welcome to this video. In this video, we will start one problem on vapor compression refrigeration system and we will solve it by using pH chart. Till now, we have used conventional method like using table in order to solve the problem. Let us take this problem. A refrigeration plant using CO2 as the refrigerant. So, the chart which we are going to select will have to be the refrigerant CO2. And it works between 25 degrees Celsius and minus 5 degrees Celsius. So, let us draw this chart on a pH plot. So, it would look like this. Vapor dome will have, then there has to be the temperature of condenser here, then this is throttling here, then we will have evaporator here, then a compression process would look like this, alright. So, this is point 1, 2, 3 and 4. So, 1 to 2 is compression and 2 to 3 is condenser, 3 to 4 is a throttling valve and 4 to 1 is evaporator, alright. So, the temperature here is condenser temperature which is 25 degrees Celsius and the temperature here is minus 5 degrees Celsius, alright. Find the ice formed per day. So, we are interested in ice formed per day. So, using this cycle or refrigeration system, we will have to find out what is the ice formed per day. But you must know that we are forming the ice from water which is at 0 degrees 10 degrees Celsius. So, you have water at 10 degrees Celsius. Okay. If we remove the heat, we will get to a point where it is 0 degrees Celsius. So, this is going to be a liquid, but this is at 0 degrees Celsius. If you remove heat still further, you will have 0 degrees Celsius, but this will be ice. So, this was water, I mean this is again liquid. So, here also you have liquid water here, alright, then you will have ice. So, this heat which will call it as sensible heat which has to be removed, alright. This heat we call it as latent heat. Okay. Now, this sensible heat we can use the equation MCPDT. So, there is change in temperature, but here in latent heat we cannot use MCPDT because it will be a constant temperature, you will get this 0, but we are removing heat. So, this has to be M into latent heat of fusion, alright. So, this has to be understood first. Now, quantity of CO2 circulated, that is mass of refrigerant, is 10 kg per minute. Okay. Now, Cp of water is given which we already know, but anyhow 4.187 kilojoule per kg degree Celsius. Okay. And latent heat of ice is given 335 kilojoule per kg and efficiency of this system is only 60%, alright. With this we shall start solving, but remember this table is also has been given, we can solve it by conventional method, but we have solved many problems on conventional method. Let us take this problem using pH chart. So, I will go to a pH chart. See, the idea is we will have to find out H1, we will have to find out enthalpy at all salient points, H3 is equal to H4 which we already know. So, if we give these values, we are ready to go for finding out the answers. So, I have this chart, we know that we are operating between 25 degrees Celsius and minus 5 degrees Celsius, alright. So, 25 degrees Celsius is here. So, let me zoom this in a bit. Okay. Now, 25 degrees Celsius and minus 5 degrees Celsius. We can find out actually 25 degrees Celsius line goes like this from here, outside vapor dome temperature constant is going like this, then within vapor dome we know that pressure and temperature both remains constant, and if you want to go beyond this, this has to be following this line, constant line, alright. So, 25 degrees Celsius line. Similarly, minus 5 degrees Celsius, I know that this is 0 and this is minus 10, see minus 10 is here, okay. So, if that is minus 10, actually minus 5 is not there. So, 0 and minus 10 will have a minus 5 somewhere here, correct. So, let us draw minus 5 here, not given, but we are estimating it to be exactly in between 0 and minus 10. All right. So, these are the two temperature lines which I am going to draw first. Okay. And the moment you draw this line, see, this is going to be our point 1. This is going to be our point 1 saturated vapor in an ideal case. So, we can straight away find out H1 here. Okay. So, we can find out H1. We can find out H1 here if you drop a vertical line. Anyhow, 1 to 2 is a constant entropy, right? So, constant entropy lines are here. If we observe, these are constant entropy lines. Okay. Constant entropy lines are here. See here, constant entropy. So, these lines are constant entropy, constant entropy. Okay. So, now if we are going for constant entropy till, so you will have to follow this line. So, constant entropy line meeting this pressure line, okay, is here. Start from here. So, this will be our 2. So, what I have done, I have taken this 25 degree Celsius line, which is going to be constant pressure after all. Then 1 to 2 has to be constant entropy line. So, this is our 2. This is our point 2. Okay. So, point 2. So, we have found out 1 to 2, then 3 is going to be saturated liquid, that much we know, and then we will drop a vertical line from here to here. Okay. So, that is isenthalpic process entropy, enthalpy constant. So, this is going to be our 0.4. Okay. So, now 1, 2, 3, 4 we can find out the enthalpies. So, that is all we want. So, let us go for enthalpies finding out. So, drop a vertical line from here, So, this is our H3 is equal to H4, correct? This is our H3. So, we are talking about when if this is 150 and this is 200, this has to be 175. So, we are maybe 160, 158, something like that. H3 is equal to H4 is equal to close to 157 or 158 kilojoule per kg. Now, similarly, let us go for measuring H1. Now, H1 is somewhere here. So, we will drop a vertical line from here so that we can measure this thing. So, we are in between 300 and 350. We are close to 325, but it is not exactly in the middle. So, we can take like 320. So, we can take H1 is equal to, so this is our 0.1. Okay, this is H1. This was our H3. Okay. So, 320 we can take 320 kilojoule per kg. Similarly, let us take H2. Now, drop a vertical line from here, close to 350, a little bit here. So, we can take 348 is equal to 348 kilojoule per kg. Now, we have all the values of enthalpies measured from pH chart. Okay. Measured from pH chart. Now, as usual, we will solve this equation of COP is equal to, now we have this equation COP is equal to, now COP is equal to heat removed divided by the work supplied to the compressor. But however, the efficiency is given as 0.6. Okay. So, first of all, we will find out QL. So, that is the heat removed. So, it is not actually removing the same amount of heat which we will get from here. So, that will be H1 minus H4. Okay. So, since mass of refrigerant is also known, let us multiply this with mass flow rate of refrigerant. Now, mass flow rate of refrigerant, if I substitute in kg per second, and if I have this in kilojoule per kg, then I will have kilowatt, all right, kilojoule per second. Okay. Now, Mass flow rate I have it in kg per minute. So 10 here. Now kg per second, it has to be minute converted into second. So 60. So 10 by 60 kg per second. So let me convert that 10 by 60. So that is 0.16. All right. So 0.16 kg per second. Okay. Now 0.16 multiplied by H1 is known to us 320 minus H4 is 157. Okay. So 0.16 into 320 minus 157. 26.08 kilowatt. Now we have been given that the efficiency is only 0.6. That means we cannot remove this much of heat, we can remove only 60% of this heat. So that will be 0.6 multiplied by 26.08. Okay. 15.648 kilowatt. So actual heat removed, we can write actual heat removed is equal to efficiency multiplied by ideal heat removed. So that is 0.6 into 0.6 into 26.08 and we have got 15.648 kilowatt. 15.648 kilowatt. Okay, 15.648 kilowatt. Now let us go to find out, had we been asked for CO2? No, actually we have not been asked to find out CO2, I mean COP. We will go for the amount of ice formed per day. Now amount of ice formed should be calculated to amount of heat removed in ice, I mean in ice making process, let us say. Okay. So in ice making we have mass of water or liquid, correct? So first is what? First is we are bringing it from sensible heat that is from 10 degrees Celsius to 0 degree Celsius water. Okay. Plus we are removing heat in the form of latent heat. So that is in the form of 0 degree Celsius liquid to 0 degree Celsius ice, correct? So if that is the case, we know that this has to be m Cp of water into 10 degree Celsius, that is T1 or T2 minus T1 minus T2, that is 10 minus 0, plus this has to be mass multiplied by latent heat of ice. Now we know that mass can be taken out common, and Cp of water is 4.187, and we know that this T1 is 10 minus 0, okay, plus this mass we have left out because we have taken common here, okay, plus HFG of ice has been given, that is 335 kilojoule per kg. We will have to check for the unit, 335 kilojoule per kg. Okay. This unit we are going to get kilojoule per kg Kelvin, and this temperature difference can be Kelvin or degree Celsius, both are same. So this is in kilojoule per kg and this is also in kilojoule per kg. Now on this side we have 15.648 in kilowatt, all right. So 15.648 in kilowatt. Now this must give us mass. Now let us solve this equation. 4.18 4.187 into 10. 4.187 into 10 is 41.87. Okay. So, in the first term we have 41.87. We have 41.87 the first term. The mass is there as common factor and this is 335. Okay. So, this must be equal to 15.648. So, now let us solve this equation straightly like 15.648 alpha equals, now the unknown is alpha x and 41.87 plus 335. Okay. Now, let us solve this equation. 0.0415 kg per second, because this has to be in kg per second. 0.0415. 0.0415. This has to be in kg per second because left side is in kilowatt. So, only if this is in kg per second we will solve it. The units are matched. Now, this is 0.0415 kg per second, but we have been asked to find out ice formed per day. So, per day means this has to be divided by so 0.0415. This has to be, I mean, kg per second has to be divided by second to day. That is, if we divide by 60, that will be minute, 60 hour, then so we will have 24. All right. So, that will go to the numerator, that will be, we will have 0.0415 into 60 minute, 60, then it will be hour, then. So, let us find out per hour. Okay. So, this will be kg per hour. So, let us find this out per hour. So, that will go to the multiplication like 0.0415 into 60, that has converted into a minute, then this will be converted into hour. So, in terms of hour, that will be 149.4 kg per hour. Okay. Now, if you want to write it in terms of per day, this has to be divided by 24. Okay. I mean multiplied by 24. So, 149.4 multiplied by 24. So, that will be 3585.6 kg per day. All right. So, we have solved one problem on vapor compression refrigeration system using pH chart. We will continue in the next class. Thank you.